This is a 1942 Philco, 1941 actually, 1942 model year. Philco, it's a 42-124. I think I explained this before, but back in the 30s and 40s, a lot of radio manufacturers released their radios like cars, where they'd release the 1942 model radios halfway through 1941. So even though this is a 42 model based on the 42 dash of the model number, this actually would have been released in 1941. You can see down here, at first I thought that this had been sitting in water and that had just eaten the finish off. But after looking this up online, it turns out that there's supposed to be a strip of wood that goes across here and on the sides as well. And you can see that's missing on mine on both sides and the front. So I have to see what we can do about that. The finish on the top and the sides is pretty bad. The finish on the front isn't too bad except for up here. You can see it's flaking off there. The rest of it looks just cracked. But we'll worry about that later. The plastic seems to be okay, just that on the top the two little corners are chipped here and here. But other than that, it seems to be alright. The dial glass seems to be okay. Of course, the dial string is broken. Grill cloth seems to be alright. A little bit of finish flaking off there. Take a look at the back. This is a farm radio, which means that it is designed for running on batteries only. See our battery plug there. There is no AC plug at all. It's only designed for running on batteries. So 2 of these pins will be positive and negative for the filament, and 2 will be positive and negative for the B+. And of course, Philco had their own special plug design for their own batteries, apparently. And this cable is not in good shape at all, so I'll have to see what we can do about that. All the insulation is cracking off all over the place. It's not going to focus on that. Yeah, almost did. Anyway, that's going to have to go. This might have to go. That's probably, that's the speaker wire. So that might have to be replaced as well. It's kind of cracking, but not in quite as bad shape as this one. So we have our nice copper wire antenna. And it's a little bit bent up at the top, but other than that, it's a nice feature of Philco's. So here's our chassis with our lock drill tubes, and there's my neighbor cutting the grass. Okay, so I was waiting for my neighbor to finish with his grass. I took the chassis bolts out. See the 4 bolts right there. The 2 pointy ones, like that, focus, like that, were 2 in the back here, and then there were 2 in the middle that were like that, and it looked like there was supposed to be 2 more all the way up in the front, but those were missing, so I guess someone didn't feel like putting them back in, which is understandable because they're all the way up in the front under here, so they're not like the easiest to get to. We pull the knobs off the front, take the antenna leads off, and you can see someone has labeled them. See, WR is for the white and red wire, WB for the white and black wire with the black tracer on it. You can see that. And then just the white wire. So get those out of the way and see if this will come out. Okay. Yep, the speaker's still attached. Not sure if that will not disconnect, so I'll have to be careful of that wire. Let me see if I can rearrange this a little bit. Actually, it turns out that the chassis stands up very nicely on its side here. So you can get a look at our capacitors underneath. I see 1 electrolytic, probably a small value one since this is a battery-powered radio. It doesn't have to do hardly any filtering since the battery's already DC. You can take a look at where our power supply wires here go. See if we can clip onto them. So here's going to be the red and the yellow are probably 2 power wires. Well, can't really see what the connections are down here. It's already been taped up. Usually these switch both the filament supply and the B+. So I would guess that one of these is probably the B+, and one of them is probably the filament. Although what I could do is check out my schematic here, so you can read it. So minus A is black, minus B is white, plus B is red, and there must be plus A is yellow. So hopefully what we can do is just put these off back here somewhere, since we're obviously going to have to replace these wires anyway, and then just strip these back and strip onto there. So, look at all of them. I think it did. Alright. So our wires are, oops, there's a string on it. Oh, these are deteriorating anyway. Let me clip them. Yeah. Alright, so this can go out of the way then. Let's cut this little knot. Okay, so now we need to strip these. So this black one is going to be minus A, this white one is going to be minus B. That one's stripped easy. This red one is going to be plus B. Yes, the other one's going to be plus A. I'm going to work on the black one. There we go. I just twisted it enough. There we go. That one's a little bit sticky. The rubber, look at the rubber has started to, you can see that the rubber started to seep into the wire a little bit. Hopefully we can still get a good connection on there. So assuming that our speaker wires are not shorting together, which they look to be okay for the moment, let's get our battery in here. So this is what we're going to use for the high voltage battery, B+. It's my little battery box. I have these holes in here set up because I have another Philco radio where instead of having one connector for all the battery terminals, it has one plug for the A battery and then two plugs for the B battery. We would use two 45-volt batteries. So if you just stick the plugs in there and there, you get the 0 and 90 volts where they're supposed to be. So you have one plug in here with the ground pin going in this hole, and the other plug in here with the 90-volt pin going in this hole, and you get the required 90 volts that you need. For this case, since we don't have that kind of setup, just see if we can get some alligator clips on there. To get the right voltage. So this is going to be, oh, maybe we can do that anyway. It's going to be 0. That goes on the white wire. It's going to be 90 on the black wire. What I should do is make sure that something's not shorted first. So for that I need to find my meter. I was trying to shoot this video in between bouts of my neighbor doing yard work. You can see if I turn this on, the resistance between the B+ terminals stays at open, so there should be no shorts in there, hopefully. I'll switch this over to volts. And if we connect up this, it should get, that's not right. That should be 90 volts. Must have a bad connection over here somewhere. Or something. There we go. 97.1 volts. Alright, so we'll just hook up our A battery connection here to the yellow wire. And let's turn this on and see what happens. These battery tube radios usually warm up pretty much instantly, so It looks we should know pretty fast. U push dropped a little bit, 91.2. I don't hear anything. That's our dial tuning. So there could be a problem with the speaker wire. Let me just check that out real quick. Let me make sure that I get 90 volts on myself here. Let me make sure that we have continuity through the speaker. That should be these two terminals right here. That's not good. So if you can see that, looks like we have an open speaker. So that could be the source of the problem. Check this directly. Okay. Alright, that looks good. So maybe it's just a bad connection on the plug. Plug it back in. .1 ohms. That's not. These are shorted out now. 0.6 ohms. So actually, before I did that, I should have checked the audio output transformer and make sure that's not exploded. But if those were shorted, that could have taken out the nope, audio output looks good. Let's plug this back in and make sure that we're not shorted this time. Okay, just double check for shorting here. 0.6, not a dead short. Hopefully you can see what I'm doing. Okay, let's put this back on our E+. Monitor that. Make sure that the 90 volts doesn't. See, 95 volts. All right. I want to make sure that our red wire doesn't touch the charger. That would be a dead short across the battery. So let's try that again. Voltage dropped and it's doing something. Still don't hear anything though, except for my neighbor doing his yard work. Something's really messed up with this dial string. So there's two dial strings, but only one of them seems to work. Does it? No, I see. There's only one dial string. The other string is for the band switch, I guess. Oh, it is two dial strings. This one's just popped off. Let me check this out for a minute, see if I can figure out the dial string before that gets off completely, but should be hearing some sound and we're not, so I'm going to look into that first. So I started checking voltages here, and I think I might have found something that might be a problem. Between ground and the B+ wire, so you have 73 volts. And then this wire goes into the output transformer, and it comes back on what looks like this wire. And when we check that, we have half a volt. You can see that's not what it should be. I can try putting in a different output transformer, seeing if that would help this. Turn this off. Turn it off now. There we go, now it's off. Should be off. Yeah, it's capacitor's discharging. Okay, so you can see, I do see a capacitor here between this point and that, which is ground. Perhaps that could be shorted, though I wouldn't expect it to draw the voltage down that low. But what we can do is a quick resistance check on that transformer. So we should be going from here to here. 5, 7, 8 megohms. Yeah, that's not good. So I'm gonna have to see if I can dig up another output transformer. Let me just make sure I'm on the right things. It looks that way. I can double check on the schematic here. Have our output transformer right here. So 76 volts on that line, and that's that capacitor. Is that the other capacitor? Oh, there's that capacitor. Capacitor to ground right there, off the output transformer. So, right, and that line comes right out the B+, the other line goes to that capacitor, into the tube, and also to, that must be our tone control. So yeah, that must be this wire right here, goes right over to the tone control down here, which has additional capacitors in it for filtering. So I think I'm going to see if I can find an output transformer. You can check and see if this is directly shorted to ground. 24 megohms, so not a hard short to ground. I'm checking on the right one, yeah. So that's not shorted to ground, so probably just a old age failure, not a short failure, since I'm not finding a short here. So let me go see if I can dig up another output transformer, and we'll just clip that in and see what we get. Alright, so I came up with a speaker, so we can use this instead of worrying about that thing shorting. This little output transformer and this bigger output transformer. I'm hoping this is an audio output transformer, not a vertical output transformer from a TV, but there's only one way to find out. We're going to start with the little guy first, because due to a chronic shortage of clip leads, I can only find one more. It'll just be easier to hook this up to the speaker like this. This already has wires on it, so I can just hook these up right to the speaker without having to find some other wires to hook them up. Problem is, I still have to get B+ to this transformer. Actually, what am I doing? Doing the wrong thing. These are not the speaker wires. These are the speaker wires. Little things right here. To verify that, check the resistance. Across these two. Oops, maybe I'm wrong. 700 ohms. Across these two. 7 ohms. So these actually are the speaker wires then, and these are the inputs. So actually I'm not going insane. So these will hook up the speaker just like that. It's just a permanent test setup, so we'll see what we can do for testing purposes. So I'm going to get this hooked up to try it. Probably have to get at least one more hook lead or wire or something from somewhere to connect the, I guess that's on, to connect the primary. So this will go over to here. stick my fingers in there. Exposed wires. So one will go to here. And then that needs to connect to B plus somehow. So let me dig around for a few more minutes and see what I can come up with for that. Alright, I was able to find this bent one, so we'll just try that out. So this would have to go from B plus, so let me see if I can, should have done that first actually. This one will clip on this wire. This one will clip on the other one. Actually, this wire goes right over here. Can I clip on? We go somewhere. I think I can. Let's try that. Make sure those aren't shorted together. Alright, so let's try this again and see if we get any sound this time. Nope, still nothing. Should I at least make some sort of... I'll turn this stupid thing off now. Should I at least make some sort of popping or humming or something? If that's not connected, let me get the voltmeter back on. Alright, let's see if I turn this on. The voltage is between, so right here we have 65 volts. Right here we have 74 volts. So that's better than we had before, because before we had 5 volts here. Let's verify that over here. And now we have 65 volts on the output tube. So the question is, why do we still have no sound? Aha, now there's a crackle. Nothing really. So when I tap, if the airplane goes away, maybe you can hear it. So the volume all the way up. If I tap here, you can hear the crackle. So, where's the volume? So nothing when I tap on the volume pot terminals. Nothing at all. There is something there, measuring negative 40 volts. And here on the other side, back capacitor, negative 1.6. That's probably not correct. That capacitor might be leaky because I have these backwards because the clip that goes on here keeps falling apart. So if this says negative 1 volt, 1.6 volts, that actually means that there's 1.6 volts on the grid of this tube, which is not supposed to be. It's supposed to be... Well, actually, no, that might be okay. Where's the cathode? I can find the cathode. Because the grid should be lower than the cathode. So, it's either that one or that one. So that's 1.3 volts on the cathode, and 1.6 volts on the grid. That's not good. Still can't turn this thing off. So that capacitor has got to go. But even with that bad capacitor in there, we should still get sound. So I'm going to have to take a look at this circuit and see how sound gets from the volume control over to this point right here, because this point has crackling on it when you touch it. So let's take a look here. Of course, if I'm in frame. So I think what we're tapping is this point right here, 0.004. Not sure what that capacitor says. So I had to cut it out to get a better look at it. Not sure if it'll. Let's see. Come on. It does say 0.004 microfarads. So that would be that one right there. So tapping here, we get sound through the speaker, just a little bit of crackling. So this, the grid of this tube goes right down to, I guess that is the volume control. So why would we have sound on the plate and not on the grid, unless this tube is bad, which is entirely possible. So let's see, this, one of these wires, this one. So this one goes up, that must be the grid right there. That grid there. So we'll put a new capacitor in place of this, and we'll continue checking, because it could also be that this plate isn't getting any plate voltage either, although it looked like it had 40 volts when we checked it, so we'll check into that. But we have to replace this capacitor first before we're going to get anything. So let's do that. Alright, so I replaced that capacitor with a 0.0047. It was originally a 0.004, but that should be okay. So let's turn this back on. See if anything has changed. Now, seems like I might get some scratching out of the volume control. Alright, so now I touch the grid. I get scratching. When I touch that, I get scratching. Alright, does tuning work yet? I'm not hearing anything. Of course, I have the antenna disconnected, so touching those does nothing. I do have crackling if I touch there. Volume's turned all the way up now. There's still nothing from touching the antenna terminals. Nothing from touching those. So let's go back to this tube, which would be the preceding tube. That should be, so taking a look at this, if we touch right here on the wiper to the volume control, which goes up to this grid, tapping there, we hear it in the speaker. Let's try tapping on the upper end of the volume control. Right, we hear it tapping there. So what connects to that? This capacitor does. Let's see if we can find that here. So one side goes right to ground. This side, which we were just tapping on, does have some sound. So it goes through a capacitor first, to 0.004. That must be this guy, I guess. Alright, so tapping on the other side of that capacitor. It's very faint. But it is audible. They don't give voltage readings for any of these things, I don't think. It says 91. I think that's just a pulse locator number, I think. I don't see what else that would be in reference to. And then it goes up to this IF can here. Which comes off that must be the detector. So the detector then is in this tube as well. So this says green wire. So that would be this. Like we just said, we do have sound coming from that. We have sound here too. That wire goes up all the way up over here. There's some paper on it or something. Right, so we have it when we tap there. Probably should be louder than this, but we don't have the right output transformer there, so that could be throwing it off as well. So we have it there. How about... Alright, so it's louder there. You have signal getting from here all the way up, but nothing on the antenna. Now there's another tube way up in here. Should we be able to see that? Alright, so we have it there. Nothing there or there. Could it just be that this band switch? Alright, that's a good sign. So nothing there. So nothing there. So maybe just this band switch is dirty. This is probably the oscillator coil. Either this is or that is. We have two oscillator coils, one for shortwave, one for AM. Also have a coil here too. There's a lot of coils in here. Okay, now I'm just poking things. See if anything gives a sign of life. So we still have it there. We still have it there. So we can try and work our way back through this wiring diagram and try and figure out which of these coils is which, or I can just spray some contact cleaner in this switch here and see if that makes a difference, because when I work this switch it does make a crackling sound. Which position is which. So we're getting nothing tuned in. So sticking to. Now they're cutting the grass at the park across the street. So I cleaned this, and then I went through and double checked the plate voltage on all the tubes, and all the tubes seem to be getting voltage. It's very faint, but sometimes when you tap on this, you hear it pop a little bit. So that means that there is signal getting from here to the rest of the radio. Now this radio probably isn't going to perform very well, if at all, without the loop antenna attached. So I think what I'm going to do is see if I can get a setup where I can connect this with all of this and just see if it makes any difference. Because definitely the signal is getting through. I'm not sure if it's loud enough. It's not that loud. Especially from the antenna, like when you hold on it. Like you don't get any static or anything, so I'm not sure what that's about. But I'm just going to hook up the antenna to see if that makes any sort of difference. Because all the plate voltages look okay. So even with the antenna hooked up, we still have absolutely nothing coming out of the radio. with the volume all the way up. Let's try the other band. Oh, we're still getting absolutely nothing. So I'm wondering if the oscillator is not running, since we're getting absolutely nothing at all. Although I'm more concerned also with the lack of signal gain. I mean, even if the oscillator isn't running, there should still be radio noise being picked up and amplified. That's also kind of a concern. I think they should definitely be louder than it is. So I'm going to go through and see if I can find any other voltages to check. There are a couple different voltages on here, and we'll just see how those check out. I wiggled the, I checked some other voltages in here and it didn't look anything like anything was that bad, so I started wiggling the tubes. I wiggled the XXB up top here, which is the RF input mixer oscillator, whatever you want to call it. I think in this case it's just a mixer oscillator. And see, we have brought reception back. And it also looks like the tube's a lot brighter now. So I think before perhaps just the filament was not making connection, maybe, because it definitely looks like you can see the filament now. I don't think you could see it before, but anyway, which isn't necessarily guaranteed that the tube is not working, because a lot of times on these battery powered, like 1.5 volt battery tubes, the filaments don't glow very bright. Right, the rest of the tubes, you can look at them and you can hardly see any filament glow at all. See if I can get in here. So that tube, you can't really see the filament. On the XXB, you can just see it right there in the corner. You can see that one too. And that's just a reflection. That's just a reflection. I don't know what I'm talking about. I didn't think that was there before, but it could just be the clearing off the dust during the wiggling allows you to see it. So I thought that was the filament, but no, it's just a reflection. Is that when it says a light on it or something? Oh, it's a reflection of my meter. See that? Anyway. See, it changed the reception when I touch it. Anyway, so something was not making connection with that tube. When you look down at it, you really can't see the filament glow, which is pretty common with these battery-powered radios. It's a bit distorted. That could be a weak tube, or more than likely, a bunch of these capacitors are not quite performing as well as they should. So I think what I'm going to do now is replace the rest of these capacitors just for precautionary, and see if that makes any difference. If it does, great. If not, that's fine. Who knows how long these capacitors are going to last anyway. And then we have to figure out whether to install this transformer or this transformer. The camera went out of memory on the last shot, so I'm not sure how much it captured, but anyway, basically all of this really needed to get fixed was the upper transformer. The contacts in here we cleaned, and wiggled that too. This capacitor probably didn't need to be replaced, but since I cut it out to get a better look at it, I'll replace it anyway, but it probably would have worked without replacing that capacitor. Anyway, so now that we've got it diagnosed, we're going to go on and replace the rest of the capacitors and get that either one of the output transformers installed and redo the battery cable.